Alright, so here's my problem. You've got two resistors, they're in a parallel circuit. There's a 12 volt battery hooked up to it. One of the resistors is 3 ohms, one of the resistors is 2 ohms. I want to be able to calculate the total current, leaving the voltage here, and then the current across each one of those resistors. Okay? So, let's talk about it. How do I do that? Well, when we looked at the problem for parallel circuit, or not parallel, series circuits, first thing we did is we concentrated on finding the total current first. Excuse me. Total current first. So in order to do that, I need to first calculate the total resistance. Well, the total resistance from the previous video is this equation. Okay? Plugging in my values for R1 and R2, I'm left with the total resistance is equal to 1 over 3 plus 1 over 2. The least common denominator for 1 over 3 and 1 over 2 is going to be 6. So I'm left with the total resistance is equal to, well, a third. Converted that into 6, multiply both by 2. I get 2/6 plus, doing the same here, half is going to be 3/6. Okay? So that gives me a total of 5/6. Now it's not 5/6 an ohm. It's 5/6 1 over an ohm. I need to convert that in there. I got 1 over RT is equal to 5/6. Okay? So that means that RT, the resistance total, is 6/5. Okay? That's the total amount of resistance I have in that circuit. 6/5 ohms. Cool? So I'm going to go ahead and write that down right here. My resistance total is equal to 6/5. From there, I can calculate the total current by using Ohm's law. Okay? So Ohm's law says V is equal to IR. Well, I already know what V is. I already know what R is. So I have 12 volts is equal to I times 6/5. Okay? Move this over to the other side by multiplying it by 5 over 6, 5 over 6. And I'm left with 5/6 times 12 is equal to, am I almost off the board? Yeah, I'm off the board. Five, 6 times 12 is equal to my current. Okay? Cool? Well, 5 over 6 times 12, well, I can bring the 6 into there and I'm left with the 2. 2 times 10, or 2 times 5 is 10. So I'm left with 10 amps. Okay? That's a lot of amps. Okay? So my answer is going to be 10 amps. Cool? Alright, so that means that my total current coming out of my voltage is going to be equal to 10 amps. Okay? I can add that down here. I total 10 amps. Now, when it hits this point that I've labeled A, that current, those 10 amps, are going to switch. Some of it's going to go through the top, some of it's going to go through the bottom. So how much current that's going through each part of that circuit, we're going to still use Ohm's law to solve it. Okay? We're still going to use that fundamental idea. Yeah. I guess that'll work. Okay? So, I'm going to use red now. I get V is equal to IR. Okay? Voltage across each one of these resistors, it's still the 12 volts. All of it has to be consumed, and these two resistors are going to consume it. So the potential drop from here to here is 12 volts. So that's how much potential drop that voltage that resistor experiences and that resistor experiences. So I get 12 volts is equal to the current, which I don't know, times the resistance. Well, the resistance I do know. In one case it's 2 and in the other case it's 3. So I'm going to split the problem up right here. I times 2 and 12 volts is equal to I times 3. Okay? Move the 2 over, I get 6 equals I, and that's the current that's going through the 2 volt, or the 2 ohm resistor. So we're going to call that I1. And then I have this coming over through here, and that's going to give me 12 divided by 3, so I'm looking at 4 amps through the 3 ohm resistor, through the bottom. Okay? Cool? So, that's circuits in parallel. Next we're going to talk about power.